On several occasions throughout this lab material, we've raised the distinction between security context constraints, or SCCs, that are available out of the box with OpenShift or CoreOS, often referred to as default or restricted SCCs, and the custom SCCs that the administrators set up as part of Brady's team in order to craft custom responses to the SCs that Amy's team was generating. Before we start customizing the SCC further to fit the specifications of Amy's SC and the containerized applications that are dependent upon it, let's examine the default SCCs, what they are, and what they're capable of. Let's examine now in detail a list of predefined SCCs that are available out of the box with Red Hat OpenShift. These are the predefined SCCs that I've mentioned in the past that, generally speaking, should not be modified or adjusted from their default or predefined parameters, as doing so will in future likely create issues when trying to update or change the version of Red Hat OpenShift, as the automation that is behind those updates and behind those procedures generally rely upon these sets of predefined, pre-available SCCs, which, were they to be modified or adjusted, will create problems upon that update. With that said, let's dive in row by row into the various SCCs that are enabled out of the box, starting with the most restricted at the top towards the least restrictive and most powerful, or those with the most privileges, at the bottom. Restricted denies all access to host features and requires pods to be run with a UID, or a user ID, and SE Linux context from the set that the cluster assigns to the project. This is the most secure SCC and is always used by default unless otherwise specified when generating a new pod or container. This will generally work for most typical stateless workloads. Non-root provides all of the same features as the restricted SCC, but allows users to run with any non-root UID. This is suitable for applications that need predictable non-root UIDs, but can still function with all the other limitations set by the restricted SCC. Any UID is the same as restricted as well, but also allows users to run both with any user ID and group ID. This is potentially very risky, as it can allow running as root user outside of the container. If used, SE Linux controls can play an important role in adding a layer of protection around that otherwise risky container. It's also a good idea to use SEC comp to filter out any undesired system calls that container might make. Hostmount-AnyUID provides all the features of the restricted SCC, but allows host mounts and any UID via a pod. This is primarily used by the persistent volume recycler, a trusted workload that is an essential infrastructure piece to the overall OpenShift cluster. This SCC should be used only by persistent volume recycler. The same warnings apply as did with any UID, but hostmount any UID goes further by allowing the mounting of host volumes. The SCC allows the host file system access as any UID, including root. Therefore, granting the permissions of this SCC is something to be done with a great deal of caution. Host network allows the use of host networking and host ports, but still requires pods to be run with a UID and SE Linux context that are assigned to the project. This SCC allows the pod to see and use the host network stack directly, requiring that the pod run with a non-zero UID, in other words, not as a root, and pre-assigned SE Linux context can add some security to this SCC. Node Exporter is used only for the Prometheus node exporter. Prometheus is a popular Kubernetes-based monitoring tool. This SCC should therefore only be used by Prometheus. It is designed specifically for Prometheus to retrieve metrics from the cluster, and applications that are otherwise running on the cluster should not use this SCC. Host access allows access to all host project namespaces, but still requires the pods be run with a UID and SE Linux context assigned to the project. Access to all host namespaces is quite dangerous, but it does still follow the restrictions of UID and SE Linux. It should only be used for the most trusted of workloads. Privileged allows access to all privileged and host features, as well as the ability to run as any user, group, or FS group with any SE Linux context. Therefore, it is the most relaxed of all the predefined SCC policies. This SCC allows a pod to control everything in the host and the worker nodes, as well as containers. Only trusted workloads should use this type of SCC. There's also the case to be made that this SCC should never be used in production, as it allows the pod to completely control the host.